Hello all. So in today's class we will look at the polar equation of a conic with focus as the pole. So we have the fixed point which is the pole, so that is taken as the focus. So in this form we will look for what is the polar equation of the conic. So you can see the figure here. So here S is taken to be the focus. അപ്പം S എന്ന് പറയുന്നതാണ് നമ്മുടെ all S X എന്ന് പറയുന്നത് that will be your initial line, that will be the axis. ഇനി here RM is the directrix to the conic, and you can see the conic which is drawn here. അപ്പം നമ്മുടെ ഈ curve ആണ് conic. So P of r theta is any point on your conic with respect to the pole and with respect to the initial line. And now RM is the directrix. So the perpendicular from the directrix to the point is PM, and the line LS L dash, that is the latus rectum. Now from the figure we are joining the lines from P to M, അതായത് ഡയറക്ട്രിക്സിലേക്കുള്ള പെർപെൻഡിക്കുലർ വരയ്ക്കുക ആൻഡ് ഇനിഷ്യൽ ലൈനിലേക്കുള്ള പെർപെൻഡിക്കുലറും വരയ്ക്കുക. P എന്ന് പറയുന്ന പോയിന്റിലേക്ക്, so the perpendicular to the directrix is the line PM and the perpendicular to the initial line is PN. So and again LQ, അതായത് ലാറ്റസ് റെക്ടത്തിൻ്റെ എൻഡ് പോയിന്റിൽ നിന്ന് നമ്മുടെ ഡയറക്ട്രിക്സിലേക്കുള്ള പെർപെൻഡിക്കുലർ വരയ്ക്കുക, that will be the line LQ. Now as we know, conic is so by a point on the conic P of r theta, so that is the locus of all points such that the distance from the focus to for a given point P of r theta to the conic. അപ്പോൾ P of r theta എന്ന് പറയുന്നത് that is the locus of all points such that it has an equal ratio, അതായത് E will be equal to SP by PM. So when you take the distance from P to the focus and the distance from P to the directrix, so if the ratio is constant, the ratio remains the same for all the points P of r theta on the given curve. The locus of such points are called as the points on the conic. So when E is equal to 1, that will be parabola. Then you will get an ellipse and hyperbola when E is greater than 1 or less than 1. So here E will be equal to SP by SM. That's how we define a conic. Now from the figure, okay, from here you will get SP equal to E times PM. ഇനി പി എം എന്ന് പറയുന്ന ആർ എന്നിൻ്റെ വാല്യൂവിനോട് ഈക്വൽ ആണ്, ആൻഡ് ആർ എൻ ഇസ് ഈക്വൽ ടു ആർ എസ് പ്ലസ് എൻ എസ് എൻ. സോ ആർ എൻ ഇസ് ആർ എസ് പ്ലസ് എസ് എൻ, and again RS is equal to LQ. So SP can be written as E times LQ plus SN, and now we can see that L is also a point on the conic. So LS by LQ എന്ന് പറയുന്ന that is again equal to E. അപ്പോൾ LQ can be written as SL by E. So we will get E times SL by E plus SN. So this is because L is a point on the conic. So therefore when you multiply this, you will get SP equal to SL plus E SP cos theta. And now SL is the portion of the lattice rectum, അതായത് lattice rectumത്തിന്റെ semi lattice rectum വരും LS എന്ന് പറയുന്നത്. And SP will be the നമ്മൾ S എടുത്തിരിക്കുന്നത് നമ്മുടെ pole ആയിട്ടാണ്. അപ്പോൾ the distance SP is going to be this distance R, because this is same as the pole O. So this distance is going to be R. So distance from S to the point P of R theta is equal to R. And again from the triangle SNP, so from triangle SNP, ഇനി ഇതിനകത്ത് നമുക്ക് SN വേണം. So SN, or if you take cos theta, so cos theta will be adjacent side, so that is SN by hypotenuse is again SP, appa R varum. So that implies SN will be equal to R cos theta. So now we have this equation SP equal to E times SL by E is SL, then E SN will become SP cos theta. So that is R cos theta. So upon replacing SP and SL, you will get so R equal to, SL is the semi-lattice rectum, we will denote it by L. So R will be equal to L plus E R cos theta. Now, so this is the equation. So L is the semi-lattice rectum, so R equal to L plus E R cos theta, or this can be rewritten as L by R equal to 1 minus E cos theta. So that is the required equation of the conic. So here E can be equal to 1, E can be greater than 1, or E can be less than 1. So that gives the 3 types of conic. And again, so let us look at a few more equations, few more special cases. So if the initial line is taken in the direction SR, so if you are taking the initial line in the opposite direction, so instead of SX, if the initial line is SR, then the equation of the conic becomes, so instead of theta you will have pi minus theta. So we will get 1 by L by R equal to 1 minus E cos pi minus theta. So the equation of the conic will reduce to the form L by R equal to 1 plus E cos theta. So this becomes minus cos theta, so we will get 1 plus E cos theta. And if the initial line makes an angle alpha with the axis, then the equation of the conic will become L by R equal to 1 minus E cos theta minus alpha. In the equation we have seen here, അപ്പോൾ നമ്മൾ ഇവിടെ എടുത്തിരിക്കുന്നത് കോണിക്കിൻ്റെ ആക്സസും പോളാർ കോർഡിനേറ്റ്സിലെ ഇനിഷ്യൽ ലൈനും സെയിം ആയിട്ടാണ് എടുത്തത്. So instead of that, if you have the initial line to be OX, and if the axis of the conic is a different line which makes an angle theta with the initial line, so in that case the angle theta will be replaced by theta minus alpha. So the equation of the conic will become L by R equal to 1 minus E cos theta minus alpha. And again, if the conic is a parabola വരുന്ന കേസിൽ ഇയുടെ വാല്യൂ 1 ആവും. So the equation can be put in the form L by R equal to 1 minus cos theta, or this can be rewritten as L by R equal to 1 minus cos theta is 2 sin square theta by 2, or you can rewrite the equation in this form. So R raised to 1 by 2 sin theta by 2 equal to L by 2 whole power 1 by 2. So let us look at the case for the equation of parabola when you have these conditions. So the first one is when the initial line is taken in the opposite direction. The initial line opposite direction, so we will have L by R equal to 1 plus e cos theta. E 1 number, we will get the equation to be 1 plus cos theta. So 1 plus cos theta will be 2 cos square theta by 2. So the equation will be in this form. And again, if the initial line is making an angle alpha with the axis, so in that case L by R equal to 1 minus E will become 1 in case of parabola, for 1 minus cos theta minus alpha. So this is how the formula applies in these two cases when you have a parabola. Now let us look at few examples. The first problem is to find the nature of the following conics. So we are given the conics. So as you know, the equation of conic is L by R equal to 1 minus E cos theta, and when E is equal to 1, we will have a parabola, and when E is less than 1, the conic will represent an ellipse, and when E is greater than 1, so the conic is a hyperbola. So, we will first put the given equation in the standard form. L by R equal to 1 minus E cos theta. So we will find out what is the value of E. So then we can classify our conic. So the first problem is 5 by R equal to 2 minus 2 cos theta. So that implies we will write it as 5 by 2 by R equal to 1 minus cos theta. So it is in the form L by R equal to 1 minus E cos theta, where E is equal to 1 and L is equal to 5 by. So therefore, the conic is a parabola, and the semilateral rectum is 5 by. And we take the second equation. Second equation is 1 by R equal to 8 plus 5 cos theta. So that will be equal to 1 by R equal to 8 into 1 plus 5 by 8 cos theta. So if I am dividing by 8, we will get 1 by 8 by R equal to 1 plus 5 by 8 cos theta. So E will be equal to 5 by 8, which is less than 1. So that is an ellipse, and L will be equal to 1 by 8. So the semilateral rectum is equal to 1 by 8. And the third problem you have 8 by R equal to 4 minus 5 cos theta. So divide by 4 throughout. So we will get 2 by R equal to 1 minus 5 by 4 cos theta. So E is equal to 5 by 4, which is greater than 1, and L is equal to. So therefore, this is going to be a hyperbola. So that's how we classify the different equations. Is to find the points on the conic. 9 by R equal to 2 plus root 2 cos theta, whose radius vector is 3. So we need to find the points on the conic such that R is equal to 3. So R is equal to 3, so that implies we will get 3 equal to 2 plus root 2 cos theta. So we need to find the value of theta satisfying this condition. So we will get 1 equal to root 2 cos theta. So that implies cos theta is equal to 1 by root 2. So therefore, we will get theta equal to 5 by 4 and minus 5 by 4. So therefore, the points are, required points are 3, 5 by 4 and 3 minus 5 by 4. So these are the points where the radius vector is equal to